I'm sure you are enjoying the advanced NLP playlist, guys, and we discussed LSTM in detail in last video. Let's go ahead and build a project in LSTM and try to understand how this model works in Python. Let's do that. Let's try to build a LSTM model in Python. Okay, and the use case we are going to perform is next word prediction use case. So the meaning of this is I give a sequence of words, okay, and my model should be able to tell me what should be the next word in this sequence. So for this, we will need some training data and we will train our model so that our model is able to predict what should be the next word in that sequence. Okay. First, let's understand some basics about how the training data will be. Suppose the corpus or the sentence in front of you is my name is Aman. Okay. So how the training data will be prepared from this entire corpus is you will prepare features. Okay. You will prepare features and you will prepare a response. This is basically a supervised learning problem. You will prepare features and you will prepare response. Suppose the word number my is first word, name is second word, is third word, and Aman is fourth word. So how your features will look like is one, when there is my, then the prediction should be name. Okay. When there is my and name, when both these are together, then the prediction should be is. When the input is my name is, right, then the output will be Aman. Okay. So this is how you will prepare your training data for a supervised learning problem based on your corpus. Fine. Now I'm going to show you the corpus which I will use in Python. So as you can see, guys, this is basically an article of Indian Prime Minister visit to the USA recently. You can see here following a lavish state visit by Indian Prime Minister Narendra Modi to Washington, US President Joe Biden. So all these things is basically comes from a news article. I will take this article, I will train my model and I will try to predict if I give some input sequence, then what will be the output. Fine. So as I was telling you, if you compare this corpus with my small corpus, my name is Aman, right? Then in this corpus, how the training data will be prepared? So training data will be the first word following, right? The first word following. If model sees this word, then the next word should be A. If the model sees following A, the next word model should predict is lavish. If the model sees following a lavish, the next word model should predict is state. If the model sees all four words, the next word model should predict is visit. If you have understood this, you have understood the concept of how the training data will be prepared. Remember, the length of all these will be different. So in first case, in this case, only one word I am giving as input. In second case, two words I am giving as input. In third case, three words I am giving as input. Okay, that does not matter much. Our model should be intelligent enough to predict the next word given on any length. But when we are training, we need to keep a track of this by padding the length of this. Okay, so padding is an NLP concept, which deep learning concept, which I have explained many times in my videos. You can watch those. Having said that, let's go ahead and try to build this in Python. Okay, so I'm importing here packages, guys. Most of these packages I have used and explained you in RNN videos. The link is right here. If you have not watched, please watch that. Apart from one new package, that is LSTM here. Okay, because I'll be using LSTM model. Now what I'm doing is I'm importing the same text here. Same text following a lavish state visit by Indian Prime Minister. And you can see some, there are blank lines. So spaces are there and new lines are there, right? So what I will do is I will process this line by line. So if you go to my text, right, this is one complete sequence. The first complete sentence is one complete sequence. Okay, this is one complete sequence. So based on that, I will process this one by one. For example, this is one, this is another, like that. Okay, so let's go to the model. And first of all, I need to tokenize this, right? I was telling you here, right? Every time you are working with text data, you need to tokenize it. So you need to break the sentence into different words and assign these words a number. Okay, so this is a very first process that you do in any NLP task. Same process I'm doing here. If you see, I'm just breaking it into text by calling fit on text. Okay, and I'm just creating a number for all the words. For example, the word the will be known as the first word, to will be known as the second word, in will be known as the third word, and so on and so forth. Okay. What I'm going to do next is I'm going to prepare my sequences. Sequences means I'm going to prepare, okay, these words occur together in a sequence. So how I'm going to do? I'm going to run a for loop here. If you see, I'm saying my input sequences is equal to blank. Then I'm saying for line in my text dot split on new line. So I'm saying split this entire text on new line and print line. I'm just printing line just to make you understand what I'm trying to do in this for loop. Okay. So when I print line, right, you can see all these lines are coming one by one. This is first line, this is second line, right? And let me uncomment this and comment what will be the tokens. Okay. So in this line, what are the tokens? So for example, first line, word number 99, 4, and 177. Just pay attention to these three words, guys. 99, 4, 177. Okay. So if I go to my corpus, 99 should be following, A should be 4, and lavish should be 177. So let me see in my text, 99, you see the word number 4 here, A. 99 should be following. Okay. So if I go here, 99 should be following. Okay. And 177 should be lavish. 177 should be lavish. See, 177 is lavish. So what I'm doing here is I'm just creating a numeric representation of the text that you are seeing in my corpus. Okay. This is very simple to understand. After that, what I'm doing is for I in range of 1 to length of token list. So I will go in all this one by one and I will see how the words are occurring together. So let me print it and show you. It will be very easy for you to understand. N-gram sequences, my n-gram sequences. I think some mistake here. My n-gram sequence, name n-gram sequence is not defined. Okay, here it will be my n-gram sequence. Okay, so if I print it like this, then you will be able to see that I am taking all the combinations just for the training purpose. So as I was explaining you here, right, in theory, first, what if model sees only, what if somebody enters only first word, okay, then first and second only that thing is there to learn, right? What if somebody enters two word, then two words and three word, this will be one combination, right? Then what if somebody enters three words, fourth word is the combination to learn, right? So here what I'm trying to do is I'm trying to say when word 99 is there, then 4 is there. Now three combination, when 99 4 is there, then next is 177. When 99 4 177 is, next is 50. When 99 4 177 50 is, next is 34. When 99 4, like that, right? So based on if somebody enters how many words, it will predict the next word. Okay. So based on that, I'm preparing my input sequences. Okay. So my input sequences will be prepared, and in the my input sequences, right? So in my input sequences, all those sequences will get stored. Now what I'm going to see is I'm going to see max length of my input sequences, and I'm going to pad sequences. Now if you don't understand padding concept, guys, I have used it many times. This is just to make sure that all the length are same for your training purpose. Okay. Once I pad this, you can see input sequence, and let me try to show you the very first sequence here. Okay. See the very first sequence here. This is 99.4. This is your 1x. So suppose this is your first record. So what I mean to say to you is when you see 99.4, right, that is my name. Okay. When you see this is 99.4, right, and if you see the one, right, you will see 99.4177. So this data is basically my name is. Okay. Now what will happen is we will break it into features and targets. So as I was telling you, apart from last word, right, last word will become target and everything else will become feature. So if I have to break, for example, this one, then what will be my feature and what will be my target? 99 up to here, whatever I'm highlighting in blue, will be independent features, and 177 will become target. Okay. If I have to take the first one, what is the feature and what is the target? Whatever I'm highlighting here is the features, 4 is the target. Okay. So same thing I'm doing here. In X, everything up to the last one. In Y, only the last one. Now let's see here, guys. X is there and Y is there. Now let's compare again with the corpus. It will be very easy for you to understand. So let me take X0. You see in X0, what I'm saying is this is my input. Word number 99 is my input. And what is my Y0? Y0 is 4. So where from 99 and 4 are coming? Go to your corpus. Following is your 99 number word. A is your 4 number word. Okay. I hope this is clear. If this is clear, then everything is clear. Okay. So 1, what is my 1? 99, not input sequences. I want to see X1. 99, 4. 99, 4 is my input. Okay. And what is my output in this case? It should be 177. So what I'm telling to model, every time you see following A, the prediction is Labis. Okay. So based on that, now one more thing we have to do before training the model, we have to convert this Y into one hot vectors, because that is how model will take it. Okay. So just from tf.to categorical, I'm converting Y to one hot vectors. It's very simple to understand. One hot vectors means everything else will become 0 apart from that word which you are trying to represent. So for example, for the first observation, fourth word, right, should be 1, everything else should become 0. So 0, 1, 2, 3, 4. If you see fourth is 1, rest everything is 0. Okay, rest everything will be 0. I'm seeing Y0. If I see Y1, right, then 177th number should be 1, everything else should be 0. So if you see here, wherever 177th will be there, right, that will be 1, rest everything will become 0. So just a one hot representation of Y. So what we have done till now, we have prepared our X and we have prepared our Y. Now let's go ahead and define our model. So I'm taking a sequential model, I'm adding an embedding layer. All these things explained in my RNN video, nothing new here. Just one new thing, LSTM 150 units I'm taking, so that I should be able to get a good result. And I'm taking a dense layer in the output and softmax, because this is a scenario of classification, right? Multi-class classification basically. So I will take this and I will prepare my model, and on 100 epoch I will train this model. Okay, so let me train this model here on 100 epochs. So when the model is training, let me explain you what I'm doing after this. Okay, after this, what I'm doing is I am taking something known as input text, that is my India. For example, I will try to predict. Okay, so input text I'm taking India, and predict next words I'm taking 2, which means after India, predict next 2 words. Okay, so what I'm doing in this for loop is how many words I need to predict, right? I will take that in a loop, and I will just pre-process my token. Pre-process my token means what is my input word. I will pad sequence. Okay, whatever the pre-processing I need to do, I'm doing here. Then I'm predicting. Okay, and once I predict, what I do is I just add that prediction to my input, so that next prediction should be better. Okay, so if you see here, I'm saying input text is equal to output word. So what will happen is, suppose India comes. Okay, India goes into the model for prediction, and a new word, let's say Aman predicts. Then in the next iteration, what will happen is India, Aman both will go as the input, and third word will get predicted. Okay. So what I'm trying to do in this for loop is I'm trying to enrich the experience of my model. So suppose any length you want to predict. Here I'm trying to predict 2 length. Suppose I want to predict 3 length, then this for loop will run 3 times. And every time this input text will get updated with the prediction. Okay, so what will happen is it will make my prediction rich. That is what the target here. So I will give you this notebook, guys. You can take it from my GitHub and you can do your experimentation. All in all, what's happening in this for loop is it is taking the input word, it is predicting the next word and sending it back to the model for the next word prediction. And finally, when all 3 words will be predicted, it will give you the result. Okay. So I will pause this video for some time, because as you can see, I have run for 100 epochs, 20 epochs are running. Okay. It may take few minutes. I will take a pause here and I will come back when 100 epochs are completed. So guys, the model is trained now, and I'm going to give a input text, for example, here India, and I'm going to tell to the model predict next 2 words. Okay. So when I run this model, as I was telling you, I'm printing knowingly here the tokens so that it's easy for you to understand. So what will happen is in first round, 6 is token number India. Okay, that will go as the input, and the prediction will be 5 number word. Okay, so 6 5. In the next iteration, 6 5 both will go as the input, and the prediction, final prediction, will be India and the. Okay, so suppose I make it 3 words. I want to predict 3 words, and I'm giving India as the input. So let's see what is the output here. So India and the US is the output for next 3 words. So if I want to change this for something, let's say this, okay, US president name, and I want to predict next, let's start with 2 words. Okay, so if this Joe Biden is the input, then what is the next 2 words? This is the 2 words. Okay, let me make it 3 words. So you will see here some meaningful information will come. Joe Biden and Indian Prime. Let me make it 5 words. So what makes sense here is Joe Biden and Indian Prime Minister. Maybe I'm assuming that might be the output. Okay. So as you can see here, the output is Joe Biden as Indian Prime Minister. And after this, the next word should be Modi, I believe, because that is the name, right? So if you see here, that is exactly what I was saying you, right? So this model is doing good based on the input that we have given. The input is very small, right? This corpus is very small. This is not a large corpus. So this input we have given, and what we are doing here is every time our model is predicting a new word, right? We are feeding that word back to the prediction mechanism and telling, take help from this and then predict the next word. Okay. So as you can see, this thing is happening here and it is performing decent. So just to revise what all we did, guys, very simple things we did. We imported our corpus. We did a tokenization assigning numbers, and then we broke it into sequences. We took the sequences, we did the padding because that is a normal thing we do in non-NLP task, and then we broke the features and target. That I put lot of focus for you to understand how to break it into features and target. Once you do that, it's quite simple. We are just adding LSTM layer and making our prediction. Okay. So I'll give you this notebook, guys. Take it, play around with it, do some improvements on this, and comment me like how did you like it. And please give me a thumbs up if you like this video. I'll see you all in the next video, guys. Wherever you are, stay safe and take care.